Hi everybody, welcome back to another edition of Snack Time Science. I'm Brittany Greer.
And I'm Veronica Greer, and we're Rosie Riverdale.
During today's Snack Time Science, we are going to explore physical changes versus chemical changes and chemical reactions, which is pretty fun. Okay, Veronica, so if I tell you something has a physical change versus a chemical change, what do you think about?
Physical change, is it popping up, in a chemical change, is it making bubbles?
Okay, making bubbles, absolutely. That can be a sign of chemical change. Okay, so this piece of paper, or this piece of paper towel rather, right, is a regular piece of paper towel, right? Mm-hmm. If I crumple this piece of paper towel up into a ball, it is now a ball, but is it still a piece of paper towel?
Yes.
Yeah, so I changed its physical appearance. It went from a nice flat sheet of paper towel into a crumpled up ball of paper towel. Still a paper towel, right? It has not changed its physical state. Now, what happens though if I laid it on fire? Will it stay a paper towel?
No.
No, because guess what? I can turn this into a ball and I can reform it back into its original physical state, right? I can change its state backwards and forwards. But you know what happens in a chemical reaction?
What?
I'm going to change its physical state to the point that it can't go back to being a regular paper towel anymore. All right? So basically what we're going to add is by adding heat to this, we're going to add oxygen into the mixture, and we're going to produce something different. All right? Don't do this at home without a supervised adult. All right? So there it is, our burning paper towel. It's going to go right in the glass, right? Which is going to help to stop the amount of oxygen going into it. But there's a lot of things you're seeing there. There's smoke. It's changing color. Does it smell the same? No, what does it smell like?
It smells like when you're blowing a candle out of a birthday cake.
Yeah, exactly. We're going to put that down into water a little bit so we don't set off the smoke alarm, which is going to happen. But we observed a number of different things. Okay, so there's a couple of different things that show us when a chemical reaction, a chemical change has taken place versus a physical change. Our paper towel turned into a ball, right? But when we're looking at a chemical change, there's a couple of things that are happening. What are some of the things that can happen?
Mommy, you're holding it the wrong way.
No, I'm not. I'm not holding it this way. I'm holding it this way. Can you read it on the side?
Color change, formation of a
Precipitate.
production of gas,
Precipitate.
temperature
Bless you.
change, light release.
Okay, right? So a light can be released. If you've ever had a glow stick, shaken it up and cracked it, it created a different kind of light, which was a chemical reaction. A temperature change, right? When we lit the paper on fire, not only did it create heat, but it also produced a color change, right? It also produced a smell change, which is an indicator of a chemical reaction. And it produced a gas, right? You saw the smoke floating up in the air. Can you put that down for me, please? The other thing that can happen is the form of a precipitate, where basically liquids happen and there's a solid that ultimately results. So here's the easiest way to remember a chemical reaction, right? Is when you mix two different things together and you make something new. Yeah? So can we show everybody that with our hands? So if you have two different things, right? These are representing our different things. And you mix them together, you make something new. All right? Anytime you mix two different things and you get a new thing, you produce something new, you are creating a chemical reaction, at least in chemistry, right? So let's take a look at that with a couple of experiments. So right here, we have a lemon, right?
A lemon that is very sour.
Which has in it something called citric acid, all right? So all citrus fruit has a citric acid in it, and it's one of the things that we can use when we mix it with other things to create a chemical reaction.
And seeds.
So what we're gonna do next is we also have
baking soda, and I'm guessing we're gonna be making cake after this because we're using baking.
Not today. We have baking soda, okay? So what we're gonna do, Veronica, is we're gonna take this baking soda, and I want you to just gently sprinkle it, gently, don't actually touch the lemon, over the top of the lemon, okay? So right now we have citric acid and we have baking soda. Now the citric acid and the baking soda aren't really touching that much because there's a layer on the lemon. All right, now we're gonna add some food coloring.
Food color.
So put a couple of drops of that on there for me. Real quick. 2, 3, 4. All right, awesome. So now we've got some food coloring to see what happens. All right. Now, Veronica, I want you to take this stick and I want you to push that baking soda down into the lemon. What's happening? It's what?
It's making bubbles and things.
It's making bubbles and things.
red.
Can everybody see that? Can you see the reaction that's taking place? What's being produced, Veronica?
Bubbles.
What's inside those bubbles? What do we have to put inside of
Baking soda.
Yeah, but when we blow a bubble, when we have soap, what do we have to put into it?
Water.
When you-
Pressure.
Air,
Air.
right? So bubbles are basically liquids filled with a gas, right? So in this instance, our signs of our chemical reaction are that we're producing a gas, right? So let's take a look at that to show that gas even further. So if you have ever seen your parents use an Alka-Seltzer tablet, what's inside of this tablet is this kind of the same thing we put into here. There's citric acid, so the lemon, and there's baking soda. Make sense? Okay, so we're gonna open up our thing and we're gonna take our tablet and we're gonna put it
In a balloon.
in a balloon, right? And so now, these two are currently in their solid form. We're gonna drop them into a liquid so that they can actually mix together and make something new. So we're gonna pull this over the top of here. And then Veronica, can you shake those tablets out? Get it out of there, back into the back of the bottle. See that? And pull it open. You got it, you got it, you got it, you got it. Go, go, go. All right, now we're gonna shake it up. And we're gonna watch our balloon as we go through this. So what are we doing? We're taking, do you see what's happening to the balloon, everybody?
Yeah.
We're taking citric acid and baking soda. We're mixing them together and we're making something new. We're making carbon dioxide, okay? We're making a gas.
And she just put lavender food coloring and peach food coloring and some baking.
Yeah, so the same thing that's happening in here, the gas that's filling this balloon is what's making our bubbles. So we've got baking soda here, we put a bunch of food coloring into it, and then we have just straight up lemon juice. So if we squeeze that lemon, this is what we'd get. So drop it into there, V.
All of it?
No, just pour a little bit. Keep going. Keep going. Nice big old squirt. All right. Can you hear it? Right? You can hear how that gas is being produced. The same stuff that's filling that balloon shows us that there's gas that's being produced by those bubbles. Those bubbles are creating the same type of reaction with our baking soda that makes that bubbling effect. The same thing you make when you make volcanoes, right? Chemical reactions also happen when you're baking, right? So when you are mixing different ingredients, what happens when you bake something? Think of something we bake.
Bake?
Yeah.
Cake.
Cake. All right. So what do we put into the cake?
We put eggs.
Yeah.
Disgusting to crack. Well, that's just my opinion. What else do we do? Oh, if we're making an oat cake, we put oats in there.
Yeah, but we put in baking soda, right? And eggs. And we put in sugar and flour. And the cool thing is when we mix all those...
frosting.
Yeah, and when we mix all those things together and we add heat, we make something new. We turn those different things, right? We turn those multiple different things or two different things. Can you do it with me? We mix them together and we make something new. So we make a chemical change, right? So we can have a physical change. Yep, so we have physical change. Fold the paper. It's still a piece of paper. We light the paper on fire. We break it down into a bunch of different materials and we create new materials.
Can we actually,
You see that bubble go? And we have a chemical change versus a physical change. So there's
Can we light
all
the paper?
no. There's all different kinds of chemical reactions around you, right? Go through and explore physical changes versus chemical changes. What happens when you make a chemical reaction? Can you get it back to the original materials? What happens with a physical change? If I rip a piece of paper into a bunch of little pieces, I can probably tape it back together. It might take a really long time depending on how many tears, but I'm probably going to be able to get there, right? But if you have lemons or citric acid at home, any type of acid, if you combined an acid with a base, as we call it, right? The baking soda is the base. you're gonna get to create a chemical reaction. So if you have baking soda and vinegar, you can look at this. If you have Alka-Seltzer tablets, you can look at this. If you have lemon juice and baking soda, you can take a look at this. Mix those two things together and make something new and see what happens. If you have any type of bottle, it doesn't have to be a flask. You can also take a look at how it can inflate that balloon or the different ways that you can produce new things together, right? And you can make something new, right? Thanks so much. We'll see you soon.